And welcome everybody to the Daily Space Weather Show. Tonight we've got a segment that we're doing for the first time. We didn't even have a chance to advertise it. Been a little bit too busy, but you'll see it tonight. It's the new Ask a Particle Physicist segment. And yeah, that and lots more coming at you from the Smash News Network, least busted name and news. These are 24-hour videos. And the most action that we've seen has been in the southern hemisphere, where there was at least one M-class flare mixed in there over the past 24 hours. Also, some CMEs we'll have to cover. Here's the equatorial zoom. Some major plasma filaments. An overall decrease in solar activity for the past 24 hours. There is the northern polar region. You can see a number of large absorption features there. Those are plasma filaments. Also coronal holes and some major sunspots. Fantastic imagery there from SDO. So let's move on to remind you to press the like button. Otherwise, there could be ramifications for your souls. Or something. Check out our shorts if you haven't. Thanks to everybody who's left comments. They're always super amusing. And yeah, tell your friends and foes about the channel. Don't forget to press the like button. If you're new to the channel, press subscribe. Press the share button. Are you an influencer? Would you like to have me on your channel? Well, I might consider it. And perhaps we would consider having you on ours as well. So drop us a line. Again, if you're new to the channel, press the subscribe button. Regardless, press the like button. Help out with the algorithms, even if you're unable and or unwilling to open your cobweb-encrusted wallet and send us a few bucks with a subscription, as we offer many ways to support the channel and make a sustainable operation. Thanks to everybody who has helped support the channel. One of the ways is via visiting our links, like the links at smashomash.com, launched back in February of 2019, and welcome to the Neo-Renaissance. Visit us there on social media, etc. Smashomash.com. Another paid endorsement is Hemp Lucid. You can find a link to our Hemp Lucid storefront below this video, or you could just enter the promo code SMASHOMASH10. The promo code SMASHOMASH10. It'll save you as many percent on checkout. So help support the channel that way. If you're in the market, they make great gifts for CBD products, immune stacks, stress, mushroom, and sleep gummies, and all kinds of other products at Hemp Lucid. Today's featured product is from the Red Bubble Shop. It's the Do the Math product. And I just did some math and noticed my face was keyed out of the imagery. So there we go. Hopefully that's a little bit better. Pardon the green aura if I have one. Do the Math, featuring a large, very high-resolution image of the closest star there from SDO in 171 angstroms. That was on February 24th, I think it was. The sun was pretty active that day, so we decided to create some new products. Do the Math, 8 == capital D. Yeah, you can use that one. And of course, it is some, I guess you could say, next level emoji usage. When you want something right, do it yourself. Do the Math. Today's featured product. Math, it's not that hard. If you can do anything that requires skill, you're doing math. Your brain is a series of ones and zeros, on-off switches, essentially. Today's featured product on the Amazon shop is The Liquid Sun by Alexander Unziker. So if you think you understand cosmology and you haven't considered the idea that stars may be made of condensed matter instead of gaseous plasma, the ramifications are serious. So let's just leave it at that. That's our featured product of the day. I think the ebook is only like $10, $24 for the paper copy there. A coming revolution, perhaps in astrophysics. Another way to support the channel is by becoming a member of the Smash Team at smashomash.com/Smash Team. Our subscription services site was launched officially back in October of 2021. Thanks especially to our Gold Smash Team members. Gold level, Silver Smash Team, the Bronze Smash Team level, all of the Smash Team types. There's a gold annual paid-up subscription, a silver, and a bronze. Find out for yourself at smashomash.com/Smash Team. And let's talk about volcanoes. Volcanoes are next. So Etna's back to erupting here. Strombolian activity there. Glowing lava bombs, ash emissions, steam and gas. At Etna. Reykjanes, the aviation level remains at yellow, essentially unchanged. No eruption there yet in southwestern Iceland. Mount Mayon in the Philippines erupting. 9,000-foot ash plume. Bogana erupting in an explosive fashion. 10,000-foot ash plume over Papua New Guinea. Ibu exploding, flight level 070. Dukono exploding, flight level 120. Popocatépetl exploding, 20,000-foot ash plume. 16,000-foot ash plume from Fuego in Guatemala. Colombia featuring Nevado del Ruiz at 21,000 feet. Revenador 15,000 feet. Flight level 150. And weakened continuous emissions from Sabancaya in Peru. Again, no new eruptions there in Iceland. And here are the past 90 days of earthquake activity. There was a 6.9 magnitude quake near the deepest part of the ocean, the Marianas Trench. Not to be confused with Marinara. And by the way, we had some people do some calculations and did the math. And it turns out that many millions of mozzarella sticks would fit in the Marianas Trench. Of course, at that point it would become a reason to be the Marinara Trench. But anyway, there is a location of that quake. It was a 6.9 magnitude near the Maug Islands. Not to be confused with Long Island. And you know what? We're skipping the rest of the earthquake report. There was one big earthquake. That's it. I mean, we're moving on because of that. So anyway, radio flux is down to 179 solar flux units, a much lower level than we had. Radio flux down to 179, folks. So there's the... Oh, great. Whoops. I guess I shouldn't have pressed refresh. 178. All right, I stand corrected. Radio flux now down to 178. And let's take a look at some more solar imagery here. Here is another 24-hour video for you. That is SDO 171 angstroms plus 94. Another 24-hour video for you here, the equatorial zoom. And we've almost made it to the Ask a Particle Physicist segment. So if you've been waiting for that, and I'm sure you weren't because we only brought it up today, we didn't even advertise it at all, it will be a new weekly feature, the Ask a Particle Physicist segment. So we're going to get to that next. First thing we'll do is take a look at Earth's magnetic moment from space for the past 4 hours. So here you go. We'll let that play through in its entirety. So that's magnetohydrodynamic pressure around Earth. And let's talk about the life of a proton. So today's Ask a Particle Physicist segment will be talking about just that. What happens when a proton shows up at Earth's magnetosphere? Well, a lot of things happen, and here are some of them. And again, this is our Ask a Particle Physicist segment featuring Eugene the Philosopher. Make sure you follow him over on YouTube, Eugene the Philosopher. My favorite particle physicist, the one from Minsk, Belarus. Anyway, here's Eugene's brief explanation of what happens when a proton shows up at Earth's magnetosphere.
Alright, so the question is, what is a proton going to do when it reaches the Earth's magnetosphere? And the answer to this question might not be as simple as you think. In fact, there's at least two options. Actually more than two, much more than two, but we'll try to get a simple answer and limit it to two only. Plus, I'm only going to be talking about the calm solar wind because the, magnetic storms and stuff like that, they will overcomplicate everything even further. So, naively, if we think, well, okay, the proton, like we're sitting at the sun, looking at the Earth. Now, of course, we also ignore the, magnetic field tilt and things like that. We will perceive it as straight up or down in this case. Yeah, by the way, our magnetic north is in the south, so magnetic field lines exit the South Pole and enter the North Pole geographically. But anyways, so let's just naively assume we're shooting protons at this thing, okay, at this magnetic dipole. So if you use the left-hand rule, you would quickly realize that the protons will drift left to the left, right, and the electrons will drift to the right under the influence of this dipole, which means we'll have a spatial charge accumulation here on the dusk side. So the Earth spins like this. So here's like 6 hours local time, here's 18 hours local time. So on the dusk side, on the dawn side, I'm sorry, on the dawn side at 6 hours, we'll have a lot of protons on top of us. And at 18 hours, at the dusk, we'll have a lot of electrons on top of us, roughly speaking. This is oversimplifying, of course, which will cause this so-called magnetopause current in the front, but also the tail current in the back. Like this is the most simple picture that we will have, and these currents will also close through inertia currents. I'm not going to clarify what they are, but the circuit has to be closed. You see it's going from left to right here and here as well, which does not close the circuit, so we need something else, okay? But there's obviously some other justification for the existence of the inertia currents. We're not going to discuss them. Yeah, and which means since we have certain currents over here, the magnetic field would be severely distorted, and depending on the degree depending on the degree of sophistication you want to use, you might consider various approximations to these distortions, but roughly speaking would arrive at a field which looks kind of like this. So this, kind of a droplet shape kind of field, cometary like. The sun is to the left in this case. So the protons go like this, and the magnetopause current goes from there to here, and the tail current goes from there to here. There is a so-called Dungy effect, I think it's called, which causes these, like, strictly speaking, this should be like a line current, but it would be spread over the sheet in reality, in real plasma. So there will be like a vertical sheet, quasi-vertical here, which would correspond to magnetospheric current. So it's going to be a current like that's flowing into us from the picture. And the tail current sheet would be like flat in the horizontal plane, flowing again towards us from the plane of the picture. Yeah, and the resulting magnetic field will be something like this. So when a proton infalls onto this structure, it's going to drift under the influence of this magnetopause current to the left, like into the plane of picture in this case. Okay, so to the left, I'm sorry, on this picture. Okay, so it will be deviated to the left. So this is the short answer to the question, what's going to happen to the proton? It's going to be deviated towards the dawn side. So if we're looking from the top at Earth, this is the magnetopause current sheet, and the proton will just drift like this. If it falls like slightly to the right, it's going to be drifting like this. So it's never going to reach the inside of the magnetosphere of Earth. That's the short answer, okay? There is an asterisk, though, because it has been detected that protons, apparently from the, okay, I'm gonna show you the paper. It's free to read, so you can find it if you wish. Solar wind entry into the high latitude terrestrial magnetosphere during geomagnetically quiet times. So it says I'm just going to highlight this for you. There is little agreement on where and how plasma entry into the magnetosphere might occur, period. Okay, so I'm justifying my not very satisfactory answer to you. So short answer is it's never gonna get in, okay? But the more complicated answer, it seems like it does get into this polar cusp areas, right? Which would correspond to basically these large-scale currents, inertia currents. So from somewhere here, it might fall down. By the way, I didn't mention there's not only these two currents, magnetopause and tail. It also causes the plasma drift towards the sun, like in this circle, within this circle, which actually causes auroral currents. So it's a plasma drift within this circle. The circle is called neutral line. It's where the magnetic field is equal to 0. But yeah, in the cusp areas, you see, they've used actual observational data, they've detected some particle entry from the solar wind. Like I assume it was isotopic ratio that made them think it was ions from the sun and not from the magnetosphere itself. So apparently, like, I would assume it's the formation of double layers somewhere here in this tail current, actually. Which, again, formation of double layers means there's a way of acceleration of protons and electrons, by the way, which means they can, get enough energy to get into these cusps. Roughly speaking, like simplifying it significantly, that would, I assume, what they've actually detected, but I might be wrong. I didn't study this question in too much detail. So there you go, basically. A brief answer is proton will never get into the magnetosphere, it's just going to get deviated, okay, like this, viewed from the top, goes there or there, thanks to the magnetopause current sheet. Slightly longer answer is it still can get in through the tail. Perhaps it's the tail, I'm not sure, because again, they also discuss this and they don't really know what's happening, and of course, they're not even talking about currents, they're talking about magnetic reconnection. But I mean, I'll leave it to their conscience to deal with. Okay, hopefully that makes some sense.
So anyway, that was our first Ask a Particle Physicist segment, and I found it enlightening. You may have heard a lot of the same kind of stuff that you'd hear from Tamitha Skov, because people who get the way the physics works, they're going to explain the same things in the same way. It's almost like cycling in a lot of ways. You'll find that there's basically one way to do it, and it's the right way, and that's it. People aren't trying to copy each other. So make sure you're subscribed to Eugene's channel, by the way, Eugene the Philosopher, Philostopher. There's a T in there, Eugene the Philosopher. You can find him on YouTube. And let's get to some more solar stuff, namely the KP index. So KP 2.33 is the current situation. KP 2.33. So geomagnetically calm conditions continue. The real-time solar wind here, not super eventful. Only minor upticks happening in the past few hours, but the ACE is showing a little uptick. That's the ACE. Here's the Discover. Looks like the beginning of a coronal hole high-speed stream, folks. We already see a 15.3 proton per cubic centimeter solar wind density. Solar wind velocity here still at pretty low levels, very close to baseline levels, 425 kilometers per second for the solar wind speed. There are the GOES magnetometers, a little bit of maneuvering done there by the GOES 16 and the GOES 18. Those arcjet moments are use of thrusters, which create plasma. And let's move on to the top view ecliptic plane field plot. One of the house favorite data sets, as Earth lies in a North Pole magnetism sector, which is looking like it's sticking around here. So could be another couple of days until we see a sector boundary crossing. Here's our line of sight field plot. Another great holistic view of the sun's various fields. Here's our line of sight ecliptic plane field plot. And getting back to where we left off with SDO imagery, there are coronal holes. So that's the coronal hole situation. Here are coronal holes from SDO. And it looks like we are already receiving some high-speed wind from that large, slightly north of the equator coronal hole there. And let's get to sunspots next, since there has been a dip in sunspots. I suppose people will be stating, oh, noes, the sun is shutting down, folks. It's very dangerous. It's very dangerous. People are spooked of the sun shutting down, folks. It's completely berserk. And anyway, sunspot number here has dipped a little bit since yesterday. It was about 190. Now it's down to about 175. So 175 is around the sunspot number here at the moment. Here's our flare probability scoreboard and solar flare monitor. So we still do have a significant possibility of large solar flares. Multiple magnetically complex sunspot groups. Let's move to more SDO imagery. There is 94 angstroms plus the SDO continuum, highlighting the active regions and low-lighting the sunspots. There are just the sunspots by themselves. And not a lot of major changes happening here in the past 24 hours, which is the amount of time depicted in those series of images. One new sunspot did rise in the northeast. It's been pretty modest. Besides that, a lot of stability happening there, despite lots of magnetic organization happening in the photosphere level. Next to solar flares and energetic particles. No solar energetic particle events. Only one M-class flare. I guess you could say 2 in the past 2 days, or maybe 3 in the past 2 days, but recent C-class of flare there. And here's another 24-hour video from Solar Dynamics Observatory. The most recent M-class event did come from this sunspot in the southern hemisphere. Moving along to a star chart. And yeah, let's just curtail that. We'd like to show you where planets are going to be located in 1 week. Let's see if we can do that. There you go. There's a solar system forecast. And not sure. Maybe I've just been blacklisted from the internet. I don't know. I guess if I was blacklisted from the internet, you wouldn't be able to see this video. Would ya? All right. Yeah. So anyway, that's where things will be in a week in the solar system. Here's the astronomy photo of the day from apod.nasa.gov, stereoscopic images of Jupiter. I don't care, so I'm moving on to coronagraphs. Here are yesterday's coronagraphs. Some CME activity kicking off there. That's 102 frames from yesterday. See yesterday's daily space weather video if you'd like to know if those are earthly directed. That's why we put them out daily. That way we don't have to talk about what happened yesterday. Anyway, here aren't some more images because internet. So let's move to the LASCO C2 and C3. Here's a little closer series of images. All right, so we've got a data dump here. That's good. Hopefully your internet didn't take a dump. And there are multiple events there popping off throughout the day today. Black Friday. How black will it be? Will it be causing a blackout? Well, I doubt it, because I saw where at least one of those CMEs came from. Let's take a look at Stereo A as well. There's where Stereo A is located. We've got a data dump from Stereo A as well. And whoops, we've got a little, that's not good. We have Stereo B here on the left. Let's just get rid of that entirely. There you go. There's Stereo A's difference imagery. And we'll bring that back to a little before yesterday's video. I must have had a little oversight there showing Stereo B. That was imagery from 2014, so not too useful. So there's the scenario from Stereo A's difference imagery. Multiple events popping off today. And let's take a look at our custom coronagraphs. And looks like another earthly directed CME. So another Earth-directed CME here, likely to arrive sometime late in the day on the 27th. As we see some significant plasma motions in this area down here. Let's get in a little bit closer there. Watch right in this area here. Right there. CME popping off. And likely to have some earthly directed ejecta. Earthly directed ejecta on the way, folks. So here's a full disk close-up. That CME kind of came from this general area right in here. Right in the Earth-facing portion of the solar disk, and a little bit on the stealthy side. And let's continue on here to the extent that we can continue on. We've got imagery from Big Bear. There's the hydrogen alpha imagery from Big Bear. Still do have a lot of large plasma filaments on the Earth-facing portion of the solar disk. There is the grayscale imagery. Don't forget to follow us on Twitter if you enjoy the content. It's a great place to share. Thanks to our new Twitter follower. Yeah, singular. Thanks to our one new Twitter follower. Congratulations on realizing the Twitter account exists. We're frankly surprised with the pathetic, putrid, and disgusting state of censorship on the internet. Before we get to bonus features, and it looks like there is a CME erupting as we speak. So right up here, a flare happening, and it looks like a CME also recently occurring there. In the northwestern portion of that new massive sunspot group, just as it moves into center disk. So it could be a huge earthly directed CME there, fingers crossed on that. Next, the latest imagery regarding satellite charging hazards. We ain't got none. It's smooth sailing. Surface charging, just minor events there over the northern Indian Ocean, India, and moving into the Middle East. Goes electron flux here is chill. There are the past 365 days. And there is the forecast model. Next we'll show the layer where it's measured. The F layer. You gotta love the F layer, folks. Don't get effed about the F layer. It's at about 300 kilometers of altitude. Here it is. Here's the anomalygram. And again, things are calm in the geospace, so no big anomalies happening. Normal variations. And we can't show you the latest image because internet. We can show you the whole atmosphere model. And again, we really hope the internet comes back because we have to upload this video, so that could be really helpful. We'll also show total electron content by itself. There it is. We'll also show total electron content anomaly from the 10-day average over North America. And we did see some anomalies. They are of the high electron count anomaly for the most part, but fairly minor. Somewhat consistent, but not super high. So there you go. And I'm going to carefully avoid pressing refresh on these images, because if I press refresh, you will get a black screen. So let's move to meteorology to the extent that we can, and to a large extent we can't. So I suspect the system just needs a reboot, but we're unable to view a lot of the images and there's no way to continue with the video otherwise. So we'll show the data that we can show. Here is the clouds and fog imagery that we typically show for the Americas. And just shortening a little bit here, hey, we had the Ask a Particle Physicist segment, which will be a new Friday segment, by the way. There's the North Atlantic, and we've got a low pressure over the Great Salt Lake right now, so we decided to center the map on that. That is the shortwave radiation map depicting clouds and fog. Low pressure right over the Great Salt Lake, which means Zeus's lightning bolt is going to kill all humans, except for everybody. Pardon my sarcasm. Next, we're going to show there is new snow for the next 12 hours. We would show the next 3 days, but oh! Look at that. I must have remembered. There's new snow for the next 12 hours. There are the next 3 days. And we ain't got no GPS. We only got we got no GFS. We only have Euro model. So anyway, there's new snow over the Americas. We'll also show the weather.gov map, weather.gov. There is a brief look at the key. Here are some forecasts in a convenient GIF format. There you go. That's pressure and precipitation based on the GFS 72-hour model. There is accumulated positive snow depth change in inches. Also the 72-hour GFS forecast. Kansas going to get some significant snow. Almost all of the state there. Expected to be coated with nearly half a foot in large areas. Next, temperature anomaly forecast in degrees Celsius, GFS 72-hour model. As cold weather will persist, especially centered right on Canada. Not Canada, Kansas. Canada. Yeah, I'm not getting Canada and Kansas confused. I apologize. Last but not least, a jet stream forecast, otherwise known as the 250 millibar winds. The same model, the GFS 72-hour model. And the jet stream will break down a little bit here. The jet stream is going to calm down and stop having so much control over weather, allowing some convective forces and some warm air to have its way with certain portions of the U.S. So there you go. GFS 72-hour jet stream forecast. There is the lightning model. The real-time lightning map is not going to work out, folks, so I'm going to show it just to show that I can't really show it. It's not going to connect. We'll close out with U.S. Doppler radar, except we won't. We'll show clouds and fog and water vapor, and that's it. It's time to close out. Here's a brief recap. Clouds and fog for the lower 48, low over Salt Lake. There is water vapor. Here's me signing off. Congratulations on realizing the channel exists. And in the time between now and tomorrow, when another daily space weather video will exist, may you still continue to exist, and may that solar wind be at your back.